Hello. Right. Oh, let's make some music. Yeah, I was going to use bit set here from utils, which means not here, but sys utils array. Yeah. I guess I want to change this into utils bit set. Not very sure that works like that, I have to admit. Yep. T is the mask type, so that should be a good conversion. Integral int. I should move this class as well to utils, I think. I need this way more often. I can also use it inside array. So I can use it for array index. This thing has a few special things, I have to admit though. Can be undefined. And 0, well 0 is not really special. The rest, it looks like almost the same thing, right? Int. We have a size type. An explicit conversion to size type is allowed. It always uses int, as opposed to allowing any integral type. I can add these two. Yeah, let me do that first. It's work on my utils library, but it seems to make sense. So I did some off-stream work and I created an index class, as you can see here, which is just a wrapper around an integral value using concepts. So they forced it here to be an integral. And we're even using the C++20 spaceship operator here. And it looks a lot more compact than what I have currently in utils. I want to put this into utils, so let's edit that file and then at the same time utils. Well, how shall we call it? I guess just index.h. Utils index. Why not? Okay, so I'm going to add it. It's going to be part of array as well. So do not really have to add a header for it, but before I change the array, I'll want to test it, I think. So let's add an index here. And then we are going to move this class. To a new header file in utils. So yeah, the namespace now become utils. I still have to edit the other one. Well, this uses standard integral, so I think that comes from concepts. The rest looks okay. There's about 2 spaces at the end here. Let's remove that. We don't need concepts here anymore because I now have that in index. And then index becomes utils index. Almost everywhere I'm using this now. Oh, this is still array index. Guess it was the only place that I was using index. Try this as well. Did not entirely go right. No match operator equals using const elements type and int. Why would that happen? It compiled before. Empty. I switched from I switched to a bit set. Okay, now I'm not sure why you cannot click on elements type, which is defined up here. Ctags not see using. It should. That again, also element is not being highlighted. Everything. So something is wrong with my make ctags. Let me fix that. Which make ctags does the following thing. Change directory to the object directory and then run ctags on loads of files. That is returned by s. And then, well, let's see, s is partition utils. Oh, s does not include my source directory. Yeah, that's would be it. People sometimes ask, what IDE do you use? Well, you'll get to oops, you get to see it now. It's my Bash scripts. Here I define where my source files are. Well, there's not really a reason to do that any different than by just simply adding source here, I guess. So now at type S, we also get the source here, the only file. And then we should be able to run make tags and actually, oh, there's no .h in my source yet. Am I going to add one? Yeah. Okay, then let's just do that one separately. Is it repository base slash source slash star.cxx. Resource, make C tags. Then now we can jump to elements.t. So now I'm using a bit set instead of uint16 type, and I want to compare it with 0 to know if there is are no bits in it at all. Well, there must be support for that, right? How do I check if it's empty or not? Reset, set, reset, set, flip, all, any. Count. I think this is what we want. Any or none. None is even better. None is what I used apparently for getting a true value on it is empty. So instead of doing this, I'll have to do none. So now empty translates into calling none. Oh well, yeah, well, yeah. And then all the other things. Using bitset makes, I guess, a big difference here and there. No match for operator equals with bitset and int again. Well, this tests if in M elements, which is now my bit set, as you can see, we have M elements, which is which should be a single bit. Is it? Oh, it's a group. Well, I'm not sure. Don't add existing elements. Yeah, can be multiple elements. Okay, so what I want is I have two bit sets, and I want to make sure that none of the bits that are set in this one are set in the other one. So we're going back to my utils bit set to see if we have a support for that somehow. I guess that would be test. Test if any bit in bitmask is set. Not any at all. Oh yeah, okay. Well, this one. Test if any bit in M1 is set. This is the one that I want. So you can just pass a bit set to the test function of another bit set. And that must be false, because we do not want to any bit to be set. I'm just going to continue with make and see what goes wrong. Okay, we do something similar. This is a test that runs. Yeah, well, that's kind of clear, right? I'm just going to call test element dot m elements. Pretty sure that should do exactly what I want. Just test if there's any bit is set. Element is here as a single bit. I think I did not call it elements. I called it bit. It's a single bit. But I'm not sure if this class, which is, well, if this class has access to the private member m bit of element, namely this class is a group. Probably not, so mbit here is defined there, but okay, it has an automatic conversion to elements type, which is our bit set. So what I really can do is just leave the whole mbit out, test element directly. As soon as I'm at 20 viewers, I'll give an overview of what I changed off stream, because I made quite some changes, I'm afraid. Hoping that well, there will be returning viewers of yesterday, and I want to update them on the changes. No match for operator not. Is single bit. Well, we literally have support for that as well in bitset. Is single bit. I want to know if m elements is a single bit. Well, okay. M elements dot is single bit. And then we have could not convert operator en passant bitset, comma bitset from short unsigned into bool. So here we want to test if the element I is set. So that's a test really. Dot test. But no, you got to wonder if I still need the element index, because element index is now defined as a utils index. However, since we're using bitset, bitset comes with its own bit iterator, which also has an index. This one, index. So maybe we should just use the bitset index instead of our new index that I just created. This one is way more powerful when using it for bitsets. So yeah, let's do that. So what we really want, okay, I'm a little lost again. What was it? It's just public. It should work. Index. Plumbing. So like that. So now we changed all the element indexes to yet another type, and now I'll just hope that it works, right? Probably not. One of the things that won't work is that we invented our own begin and end. Although there's a minor change, a minor difference here. The end that is defined for the bitset index is really the end of the type that you pass. So that would be 16, right? And we want the end to be 5. But hey, we don't have type safety if we cannot use the compiler to make those checks. I just run make. We'll see what that brings us. Okay, the type const element index, aka utils bit set index of const expression variable blah blah blah, is not literal. So you cannot make const expression of it. Maybe my bit set is too old to support const expressions. In that case, we'll just have to fix it. No, it's not too old. I have to use the POD types, I think, for this. Okay, it's getting complex. Let me have a look at bit set again. This is just an index, right? Bit set index. Let me have a look at what that actually is. Yeah, see here, there's an index POD. Bet we need to use that. So index POD. We find a few handy constants. We have an index pre and an index begin. So this is literally what we want for the 0. And see, indeed the index end is defined as 8 times the size of t. We don't want that, but at least we see what the type is that we need to use. That is index POD. Let's go back. Let me have a look where the POD is used for the rest. You can do all kinds of things with it. More interesting when it is returned. It's never returned. Okay. Oh well, let's make a special element index POD. Stands for plain old data. So because it's a const expression, it must be plain old data. Don't ask me why. But not even really a reason to sign this thing, because, well, you already have it. So it's called index begin, defined inside namespace util simply. Namespace utils bit set. But for end, I really want to use n. So let's see if this compiles, if I just pass n to it. Now n is an integer. The question is, can we construct an element index an element index POD, which is elements index POD, which is utils bit set index POD. Can we construct that from an integer? And I doubt it, because, well, it takes an int 8. So it's really it is a POD, so it does not have a constructor. You have to use what is called aggregate initialization, and that means that you just pass the value of its elements, in this case just 1. And it might complain about going from 32-bit integer to 8 bits, worrying about throwing away bits. So it might be better to just use an int 8 or a byte. On the other hand, it is a constant, so it sees that 0 does fit. and in this case, right? And n, I mean, yeah, it's a constant. So either we could make this an 8 type. Of course, that's gonna fit. Or I can just leave it in int and it's not going to complain because it sees that 5 does fit in 8 bits. Let's just try it. Error index POD in using elements type is class. What is this class doing here? Where is this? It does not have a type. Okay, nobody understands this. Let me have a look at the code. Index POD is defined. Oh, it's defined in the namespace. That was nonsensical. Utils bit set. And then we get error type const element index, aka utils bit set index of const expression variable is not literal. It's still complaining about not being literal. The reason being, still talking about index instead of POD. Which is because I'm still using an index here instead of a POD. Stupidity of my part. I don't know where my POD went. Probably never added it. Then we get in static member function, static char element index to name, passing an element index, using element index is where you cannot, does not have a get value. So what I want to do here, I want to create a character where the value 0 becomes A and the value 1 becomes B and so on. And our index is now has changed from an uint 16 type to utils bit set index. It doesn't have a get value, so let's go to bit set again, and then index is bit set index, which was this class. Okay, we have an uint 8 operator, and then I have to use parentheses instead. So the get value is simply gone. To do this more often, I have another one here. I'm lazy. Make you're still already on this? Yep. Lot machine. No matching function for call to utils bit set index Da 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 da. We cannot create it from whatever this is. Well, this is going to be an int, I think. Char minus char is obviously an int. No, I don't know. Is it? Is that an int or is that a char? And then we want to create an element index from that. Hello, Sagar. So finally I'm there. I want to create this index from an integer type thing, but the only thing that it accepts is an index POD. Apparently. Yep, so we must use an index POD, which is defined as this struct again. Now this does not have a constructor, so if I pass an integer, it's not going to think, well, I know how to create this index from an index POD, and I have an integer, so let's convert the integer to an index POD. Because I know how to do that. It's not that smart. I'll have to explicitly tell it to use accurate initialization to get the index POD. It's kind of funny, I think. You have an int 8 type, so 1 byte, which is wrapped inside an index POD, which is base class of index, which has a constructor that takes that struct as a argument, and that index is defined as a type inside the bit set, which we use here. And so if we use elements.index on this index here is that thing, or the index that we just saw, and that's element index, and then that's what we are trying to create here. So yeah, it really is the same index. But creating an, yeah, no, it did change, sorry, it did change. So basically if I do this, it should work. I think. I'm not sure, but I think it should work. Because now it's going to think, let me think, pretty sure. At some point it's going to think I want to construct an element index, which is a bit set index, which can be constructed from a struct index POD. And it gets an integer. I'm not sure. Let me try. 50-50. No, well, warning. So it did work, but with a warning. And indeed, the reason is that it is considering this as an integer. It's casting it to an integer. Unbelievable. So it does have a problem with going from 32 bits to the unsigned char. For the rest, it did work. But okay, let's tell it explicitly so it doesn't have to worry about that. So we're going to do a bit set. What is a good way to do this here? think we can just go to the POD like this. Although I think it's still going to complain about narrowing indexing. I saw that yesterday, so this is probably not solving anything. So it's still narrowing conversion, still going from 32 bits to 8. But that could be solved by using a static cast then. So now instead of creating a POD, we just static casting this int. Now the weird thing is, I kind of think that's weird, but you know, you have to get used to it, I guess, that if you subtract a char, which is 8-bit, you subtract a char from another char, then the result is an int. Seriously. Hey Demir. Yes, I'm alive. Okay, could not convert 0 from brace and close initializer list to element index. Well, that's because what you really want is begin. So the reason I'm using a special type as index, even though it's just a wrapper around an integer, is that I do not want to make mistakes and confuse all kinds of essentially different integers with each other. Now 0 is an integer, so it's like worried that I make a mistake here. And the way to avoid that is to type literally what I really want here, and that is using begin. Of course, I forgot the exact name. Begin, what did we make here? Really? I have so many begins. Here it is, I think. I have an element index as I begin, which I could use. But that if I have an element, then I could have, I can call element I begin. If it is an element, but was it? It definitely was an element. So can say, okay, element I begin. Which is just a static function returning a const expression. So it's exactly the same as using 0. Except now the times, the types are correct. For group index, well, that's also not going to compile, although group index is, I think, currently not a bit set index. I use for group index, I use an array index, because I'm using that for arrays. I'm having here an array. Where's my array? So a partition exists of n groups. And to get a certain group, then we need the group index, and that's the type that is needed to get that group. So a group index runs from 0 till n. So that's not, it's clearly not a bit set index. It's not the index of a bit in a mask. It's an index into an array. And that one does support constructing it from a 0. Because array index is defined as this thing here, and it accepts an int, as you can see, as long as it's explicit. no matching function for call to utils bit set index int. So here I'm trying to initialize an element index with 0. And that was that thing. And again, here I want to set it to 0. Now I could assign an element index constructed from blah blah blah. But don't tell me that it was necessary. I can just do I begin, of course. Oops, like that. And it links. Does not partitions, I named it. It's still working. That's the beauty of type safety. You can hardly make a mistake. The original code worked, so as soon as the compile errors are gone, it just works again. Almost 20 viewers. Come on, guys. No, I'll just explain it. So, are there people here that were here that watched the stream of yesterday? I made off stream a lot of changes. For one thing, I moved it to projects. Oops. I'm now using my bash script IDE between quotes, which looks as follows. So this is the base of my project. I'm now having my debug support library, my CMake build system, and my utils library, of which we use, for example, bitset and array. That was the reason that I wanted to do that. The actual source code is just still a single file. I renamed it from main.cxx now to partitions.cxx. We now have we're now using CMake instead of running G++, yeah, from the command line, which is super short. Just saying you have an executable partitions which uses this as the source file. And there is a magic include for the projects that I'm using. So now I can just run make, which again is part of my bash script IDE. So really which make is something that in the end runs CMake. CMake build and stuff. But not to worry about it, we just can compile this now like this, and then we have here utils, the power of the utils. Oops. All of these utilities, and I'm currently using array and bitset. I don't think anything else, but powerful enough. So what did I change in the file itself? It's also quite a lot. So I went from uint16 type to a bitset, utils bitset, which is just a wrapper around this thing. But now we have, it gives me a lot of power to handle that thing as a bit mask. And this is still 5. I added a. Now you already had an element index, but the type changed. It's now index into the bitset. So the type is different, but it gives you a lot of type safety in that our element is now really specific. Our element index is now specifically suited for addressing a single bit in this elements type bitset. So element still has a debug name and a mask with a single bit set, and we also remember the index of in that bit. That's not really necessary anymore, I think, because bit set is so fast. Uses a single assembly instruction to recover the index. But okay, let's keep it for now. So I redefined the SI begin and I end in a different way, but well, essentially these are still 0 and n. We have our constructors. This should no longer be needed, I think. Let me think if that's true. Yeah, it is. Yeah, especially the end must be equal to n instead of the IN that is defined by the bit set, which is just 16 instead of 5, in case n is 5. Okay, big change. I changed my mind and I renamed elements to group, and now also group index is a type safe variable wrapper around size type in this case, instead of an int. So I used to have just we did not have this type at all. I just used int for the index into our array. But now I'm using utils array, and therefore the index into that array is also type safe, called array index. A single group, by the way, is just a bit mask with elements in it. So one or more bits being set means that the element is in that group. Now I still have the add and the remove and the toggle and the test and the single bit. Everything still exists. Maybe slightly different, but so partition now is not a standard array but a utils array, which is just a little bit more type safe because it doesn't use an int as an index, but it uses group index as an index. And I don't think that's changed very much. Oh yeah, I renamed almost everything here. I thought it was pretty unreadable, so I did some renaming, and hopefully now these members are easier to read. So the iterator that is going to iterate over, let's call them neighboring partitions. So yeah, we have a given way to partition all the elements. Then if you move one element from the group that it is in to another group, then you get a neighboring partition. You're just only allowed to move one element. If you move two elements, then it's not a neighboring partition anymore, but it's of course a neighboring partition of a neighboring partition. You just move one element, and then where you get, then you move again an element, and then you have moved two elements. So this iterator runs over all the neighboring partitions, which you get after moving one element. And then we have a copy, which is still called original. This was renamed. It's now called the number of groups original. So that's the number of groups in the original partition. And then we have the loop variables current element index, and the new group. This was called m. This was called m index, and this was called m group. So this is then the element. This is the current element that we're going to move, and this is the group that we're going to move it to. And then for each current element, we update these two variables just to get a little bit more speed, I guess. So it's cache information about whatever element this thing points to. namely the current element group, which is the group that the element is in the original, and if it is alone in that group in the original. So maybe these names are still not really descriptive, but I think it's slightly better than what it was. Okay, so this still works the same way then. This is really the kernel of it. If you do the dereference on the iterator, it's just removing the current element. It's removing the current element from its current group, and then it is adding the current element to its new group. Ooh. So it moves it. Now, of course, this would not move anything if current element group and new group are the same group. Then you just remove it from a group and you put it in the same group back, so that nothing would change. So these two must be different, and that is then guaranteed by this pre-increment operator. The test is here. So we advance the new group, and if we get to the end, we advance the element that we are going to move. And if at any moment we end up with that the new group is equal to the group that to the original group, then we do not return, but we pretend to do another increment. So it's just skipping, moving it to the same group. And that turns out that works, right? Okay, this still works. I could change this, by the way. But yeah, now I switched to the utils bit set. I would have written this differently, but okay, it still works. So what I have here is we create a default construction, puts all the elements in a single group, and then I run over all the neighboring partitions of that, and then for each of those we run over all the neighboring partitions of that. So yes, we do get back to the original. I guess we could skip that. But it's maybe good to see that it works, right? So So we start with all the elements. We have 5 elements in one group. One group means it braces here, and then we remove the A and move the A to its own group. So you get a group left without the A and a new group with just the A. And then this is the inner loop where we find the neighboring partitions by moving another element, but it starts with moving the A back. So now it's removing this A from this group again, and then moving it back to the original group, so then we get this again. But we can also move B away from this group into the group of A, so you get this. Or you can remove the B and put it in its own group, then you get this, and so on. So with, this is original, all these are the neighboring partitions, as it were. Now for the real work. What I want to do is calculate a weight. So I call it a weight. Maybe weight is not the best word, but every partition, so any way to partition these 5 elements, gets a value, a weight, a penalty. Let's call it weight. Should I call it value? A score, maybe. Yeah, score is not bad at all. I think I'll call it score. So it gets a score. The score is made up as follows. Every pair of elements gets some value. For example, BC has a value, BD has a value, EA has a value. There is no ordering for the pairs, so EA or AE is the same. It's just the A and the E together. Doesn't matter what the order is, have one value of a score. And the score of a partition is then equal to the score of all the pairs that where both elements of the pair are in the same group. So in this case, the only pairs that are in the same group is BC, BE and CE. AB is not in the same group, is not counted because A and B are not in the same group. Now, the way to find out which pairs are in the same group depends a bit. If in the end I want to really bump it up to say 64 elements, then it's not feasible anymore to run over all possible pairs and then check if those pairs exist, I think. That would be 64 times 64 possibilities, while there is maybe only one element in it. That would be kind of stupid, right? So instead, what I want to do is use the power of utils bit set, which can iterate over all the bits that are set. So we just have, in this case, we just have a bit set with 3 bits that are set. And I'm simply going to run over all the bits twice, not taking order in account. So if I am at C, then I'm starting at E, going to the left. That's definitely the fastest way to run over all the pairs. There is an assembly instruction to get to the next set bit. It's not extremely fast. I think it's more than 1 clock cycle, but it's definitely faster than whatever I can write in C++. And well, it's being used by my utils bit set, of course, speed freak as I am. So this is what we're going to do, and that way we'll be able to find all the pairs in a group. And then from there we need to find, of course, very quickly the associated score. So I think I'm going to start with that. We're going to add a new class called score. What is my last class? Last class, partition iterator. Okay, so a score is defined by I think yeah, maybe I should split it up actually. So it's not a score, it's more like a pair then, right? Score is just a double or a floating point value. Although I think I have to I hate it. You have that you're just suddenly one of your ears goes half deaf. I don't know what it is. Can be really good, but usually it returns to normal, so I'm not worried about it. Yeah, the actual score is a float, but I also want to be able to talk about a single pair of 2 elements. I think that makes more sense, right? So we're gonna do element pair. And I'm going to store the element pair also as a bit set. Yeah, because elements type is a bit set. So in this case we just have 2 bits that are being set. That now we know what the pair is. Hello Ramchandra Reddy Seri. Well, I must be able to construct it. There's no default constructor, I think. Well, you could make an uninitialized. You could need to construct it. Default constructor. For example, if you make a vector of these things, and probably need a default constructor. After which they are all undefined. So I could say M element pair might have no bit set at all, in which case we just mean that it's an undefined thing. Well, let's just do that. Okay, so construct an undefined element pair. Now what happens if I just use the normal default constructor? Dus as you know, default constructor means that we pass no arguments, and this default is another default. It's what the compiler comes up with. What the compiler normally comes up with is just calling the default constructor for all of the elements. So if you do it like this, it's going to just default construct elements type, which is a bit set, which has a default constructor which doesn't do anything, meaning that the base class here, which is the POD which contains something, is uninitialized, and I really mean uninitialized in this case. Can have random values that were still on the stack, wherever that is. So that's maybe not what we want, but on the other hand, it really doesn't matter, because we should never be using that value. If you do this, yeah, it's 0, many bits, I don't care. You should not use it. It has to be assigned later on. Of course, it should also be possible to create the pair directly, passing 2 elements. Element 1 and an element called element 2. Now, does it make any sense? Let's have a look what element was. Element has a name and an index and God knows all what, so maybe it's a bit big. To store, but not to pass. I could pass an element index, and in fact, no. I'm not sure. Maybe I should pass an element index, but on the other hand, if I have an element index, I can automatically convert that to an element. Would be minuscule slower, but I mean, I don't really want to confuse element and element index all the time. The stupid element is wrapping the element index. We should remove that. And you can make this explicit debug code so that well, once we're done with debugging, it doesn't even exist. And I can remove this one because it's easy, they're just containing the same information. And then it makes sense to use element as a mask. Or use element as an index, whatever is easier to use. But this whole thing is a test, so you're always going to need a name to print. And I don't know about this. So I'm just not going to worry about the speed and performance implications because of the size of this thing. It's not that big. A quick look. Elements type is 2 bytes. This one is 1 byte, and this one is elements type index. It's also 2 bytes. It's probably smarter to put this at the end, although it shouldn't really matter. No, the total size of any class must be a multiple of the alignment. And these two are wrappers around 16-bit integer, which are aligned in C++ as well, to an address, an even address, of course. So the whole size of element must be divisible by 2. So even though this character is just a single byte, it's going to have a size of 6. 2 for that one, 2 for that one, 1 for that one, and 1 padding. And if I put it up front, we get just 1 here, and then 1 padding, and then 2 for this one, and 2 for this one. Size stays 6, doesn't really matter. Might as well put it here. But I digress. Let's just pass the element. Not worrying about the index. Now I have to implement it. And then of course we need the index. Mwah. Ah. Yeah. I think this is really just the OR between 2 masks. So I can make an elements type. Okay, I changed my mind. Let's use index here. Or not. What shall we do? It seems to be the more natural thing. No, I'm not. Damn it. Help. Okay. And if you have no idea anymore, you just type in what looks nice. Element 2. So this is basically what I want, right? They are basically under the hood. They are masks. And I just want to combine them. The only worry here is that element 1 would be equal to element 2. And if it was a serious program, I would definitely add an assert for that. I could add an assert here that element 1 is unequal element 2. But hey, well, a single element is should be a single bit, so then I also have to add maybe you can only construct this from a single index, so it's never going to be more than 1 bit. Of course, this bit mask could have multiple bits set, but it's just not going to happen because there's no way to to do that. You can only pass an index. So only that one bit is set. We do have an automatic conversion to elements type though. So if we use an element somewhere and we need an elements type, it's just automatically going to convert it to that. So hey, this works. This is just going to be converted to an element type, and this one is going to be converted to an element type, or is it? I really hope it is. Because then it can find an operator or, because my elements type is a bit set, which obviously has an operator or somewhere. Here they are, this one. So that would be this one. But I'm not sure if it's going to find it, but then is the compiler smart enough to see that it can find the operator or if it converts both of them to element type first? I would almost be surprised if that's the case. Let's try it out. Nope, not smart enough. No match for operator or. Now it would be smart enough if we convert one of them to explicitly to an element type. So I can do this because we have this operator elements type. I'm saying I want an elements type, and it says, well, I have an operator elements type, so I know how to do that. Okay, you get it. And then we are looking for an operator or that has an elements type on this end and something else on the other end. It's going to find an operator that has elements type here and needs an elements type here. And then it might be smart enough to say, hey, if I convert this one also to elements type, I'm going to have an OR operator. So just being curious. Let's see if now it compiles. And it still doesn't. Oh, I typed it wrong. Set a cost. Seems that that worked, but it has a problem with the unequal operator here. And for exactly the same reason. Is that really true? Why would I not be able to compare, to use unequal on two element types? It's surprising. Let's have a look why that is. Operator. We do have an operator unequal here, but bit set and bit set. That? Yeah, that should work. Okay, that's weird. Oh, no, it's not. It is exactly the same reason. I'm just being stupid. Exactly the same reason. I mean, I can compare the element pair, elements type directly, but I do not have the element pair variable here. I just have that element pair. So I would need to add again that cost. And then again it should work. And now it does. But yeah, it doesn't really look nice, does it? We had something nice and now it's not nice anymore. So what I really want is that I do not have to, that I do not need to have to do this. I just want to have an operator directly for my element. I want to also be able to compare elements directly. So that's this element here. Now in this case we have an elements type, and then the right hand side is an element, but now it's going to use this, because now this is already static casted, as it were. So, I mean, we are using m-bit, so that would be the same as a static cast on element would use this, and then we have in fact the m-bit. Well, that's exactly what I get after static casting element to elements type. And then it did find the operator, because now for this one it's just going to try and then find the existing elements type or elements type, and then it's going to say hey, but I can convert this thing, this element, to an elements type. So this should compile. No casting required anymore. And for the same reason then we can also make a beautiful unequal. And then while we are at it, we probably should add the AND all the other operators as well. Although I'm not even sure if it doesn't do that automatically. What happens if I only define the equal? Does it then say, okay, I need an unequal, but I can implement it in terms of the not equal? It's probably also too far-fetched. Oh, it still doesn't know the OR. What? Cannot convert bit set to bool in return. It's, oh, OR as a bit set. Yeah, of course. That's nonsensical. Why is it a bool? I think I wanted to return an element again. So now maybe it has a problem again, because now this one is an element type. It can find an operator OR for an element type on one side if the other side is also an element type. But the other side is an element, but it knows how to convert an element into an element type. So, and then if we apply that, we get an element type. And then it has to return it, but the return value must be an element, and say, ooh, it must be an element, but I have an element type. So then it needs to have a constructor. We don't have a constructor for an element type. You know what? If I add that, it's going to work. But it cannot be explicit, because it's you know, a compiler is looking hard for something, and say, well, we can do this as an implicit conversion from elements type to element. But that's implicit, so you have to just add it like this. If I put explicit in front of this, then I would not be allowed to do that conversion on its own. But then we still have to implement this, which is not easy at all, of course. Now I have to get the index back, which would mean the bit index of the single element. Fortunately, now this one is a utils bit set, and that does have support for that, as I mentioned earlier. So I can do name. Now I'm feeling like moving the name to the end, because we have to initialize them in the same order. So let's put that one at the end. And here too. And then I can just do here, we begin with mbit. Mbit is just elements. Now it's going to use this automatic conversion for that again, so we don't have to worry about that. And then the index. Well, now we have to convert our bit set to the index. So I have to look at bit set again. How do we get the index here? That might not be 100%. I think this is it. It is easy. You turn the index to the least significant bit. The least significant set bit is immediately the index. I think, or this one, because there is only one bit, it doesn't matter. Is one of them faster than the other? I think this one looks fastest. It's just calls CTZ, and logarithm also calls something like that, but it has to do more work. It calls CLZ, but yeah, tertiary operator and stuff like that, and equals here. So the log2 is slightly slower. This also has a tertiary operator, but well, I think this one is faster. So let's call this one. I could add one that is specifically for bit sets where I know that there is only one bit set, but we don't have that. Okay, so the least significant set bit index. Whoa, I used an abbreviation. Normally I don't do that, but in this case, I think LSSB is already being used by some people everywhere in other libraries. And then the reason that I put it at the end is because this one requires the index. And now we have the index, because that was initialized first. Otherwise I had to call this twice. Okay, so now we can construct this thing from just elements. And of course it's not elements at all, it's just a single bit. So either I'm calling it element, or since this is an elements type, I'm going to call it bit. Yep. So then this one should also work. Let me try to compile this because it doesn't work yet. Oh no, what all is wrong? Ambiguous. Overload for operator not. Okay, well, I don't care. So this didn't work. It's not really that smart that it can convert this. Plus it was wrong because of after this. Well, anyway, you have to explicitly add this, and then what you gotta wonder is if I mean, I just need unequal. It seems I need only unequal. Let's get this to work first. Required static assertion field. The type of the argument to CTZ can only be unsigned. Ooh. I don't think that makes any sense. Shouldn't this be my unsigned int here? Oh, sorry. Okay, it can only be unsigned. It is unsigned, but it's not unsigned. That is the problem. It can only be unsigned int long or long long. So an unsigned short is not possible. Well, I don't think it's a problem to cast that to an unsigned int. Because the bit index doesn't change. But yeah, it's buried inside our bitset type. It's not easy to cast. Maybe you can just repeat the actual underlying stuff. I could cast the m-bit mask here, I think, for the case that it is if t. So if the type of the bit mask itself is less than an int in size, why not just cast it to an int, unsigned int? It's undefined on n equals 0. So we know that one bit is going to be set. If t is shorter than an int, I have no idea why we would not just call this. And now is why do you use const expression and not const in this case? Because if you use const, it's not a const expression, and therefore you cannot use it in a const expression. But declaring that this is a const expression function, I am allowed to use the result and the whole function in a const expression, aka it will be called and evaluated during compile time. For example, I can just define a constant somewhere which get past a mask, which is a const expression. So I have a const expression with a mask, and then I have a const expression which is the index of the least significant bit set in that mask, and the compiler is going to do all of that during compile time. If you use it, if I leave away exp, so it's just const, might as well leave everything away, and then the compiler is going to say you cannot do that. I think this whole static assert doesn't make any sense, in the sense that there is no problem as long as it's unsigned. So unsigned short should also be allowed. I switched to C++20 completely anyway, so I might as well use concepts here. It's not a concept for an unsigned integral. Let me find that. It's probably called std unsigned integral. I'm not sure, of course, but so yeah, I'm going to change this, I think, into I'm still bad at concepts though. Is it a concept? Can I just use here standard unsigned integral? I'm not sure, so just try to compile it, I guess. And then now we are using concepts. Seems to work. Yeah, so that works. So then I can remove this No, now we got also unsigned short and unsigned gars, and any call will do. But I only defined it for these, but it's going to automatically convert them to unsigned int. There's no problem to have an unsigned short and then call this function. Just unsigned int can contain all the unsigned shorts and unsigned characters as well. So this works as is. Now it's ambiguous. What the hell? Really? Yeah, it cannot decide between unsigned int long or long. It's kind of surprising me. I would think that it would just always pick int in, but okay. Apparently not. I'm going to turn this into a template, I think, as well. I don't know, it's as if I have become better at C++ since I wrote this, and let's see. I wrote it in 2019, so that's only 3 years ago. Surprising. So we just define it for T, which is an unsigned. Dips. But then we call the wrong built-in for these two, so I'm going to make specializations. I guess just like this. Dear mouse. So now every type is going to use this, unless, well, every unsigned integral type is going to use this. So also the unsigned char and unsigned short and unsigned int. But unsigned long and long have specializations. So then if it's unsigned long, it's going to use this one, and unsigned long is going to be using that one. And that worked. Great. Yeah, I forgot what I was doing, really. Yeah, the last thing that I defined was an operator or somewhere. Or exactly not. And the question was, shouldn't I also add the other operators, like and exclusive or and all whatnot, defined by bitset. Let's see what bitset all has. Go back to bitset again, and we have operators for way down. I mean, there's a lot of other operators which you just skipped over. But if you add or, then why not add and, right? Or is that nonsensical in this case? I might want to check, you know, if something exists. So then and makes sense. And exclusive or would be, well, toggling stuff. I mean, yeah. If you add one, you can add the other ones. I'm not going to add this though, I think. I mean, maybe eventually when needed, but not right off the bat. So they just stick with these three, yeah, in total. And I'm not sure if the operator equals will work if we have an unequal. But I think it should, and so I'm not going to add equal until I run into a compile error. And for now we also do not need less than. I mean, for certain ordering it would be required to add a less than, but it definitely doesn't make any sense to say this element is less than another element. Does that make sense? Maybe. Yeah, we have an index, so that we do have kind of operator stuff, compare operator stuff. Ordering, okay, ordering. For the heck of it, let's add the spaceship operator. For comparing the right hand side, it's all the same thing, right? Now, Russ, do you recommend going into C++20 for embedded devs? I'm not an embedded dev, so I don't know. I have absolutely no clue what the requirements are for embedded. I work on a high-end PC, and it's my only interest, or experience for that matter. Okay, so what were we doing? Right, I was going to, I was adding a class. Element pair. Yeah, so now we can construct it from two elements, right? Yeah. What else do we need? Oh, we need to be able to print it. Print on standard stream reference OS const. I no longer should use my need my operator less than because I'm now using my own systems, which just picks up the fact that print on exists. Let's test that out. So I'm going to make a pair. Well, let's just not do this anymore, so I'll keep it as example. Let's keep one of them as example. Element. Well, let's say you have a C and E. So defined up here. I won't be able to print it. Definitely not going to work, but then we make it work. So yeah, basically this bookwork is saying that we don't have an operator. Operator less than for element pair, but I don't want to add it. Oh, it's complaining about something else as well. Warning in C++20, this comparison calls the current function recursively with reversed arguments. Yeah, we cannot use the automatic conversion there. Just have to compare two element types directly. And the operator stuff is defined in somewhere in here, I think. I hope. Or not. But if it's not defined here, then where would it be, right? So there's something with print on. There is a print on here. So I guess the only thing we have to do is include this header. I think I had a catch-all or something like that. Yeah, this is something else. Detail print on. Let's see if I can find it. I cannot find it. I'm just going to try and include this header and then see if it works or not. Nope. Well, then maybe we need something from utils. That is very well possible. We have a stream thing here or not? I'm blind. So maybe that one then. Let's have a look at it. vi./utils debug hosting operators. Search for print on, no print on. Oh, it's almost empty. I think what I have to include is something that has a has. Ah, here it is, has print on. That's probably what I need. Let's have a look inside of it. Yeah, here. Gets all operator less than for classes with a print on method. In order to use it, you have to add this to every namespace that contains a class with a print on. Okay, my memory has been refreshed. Well, our current namespace is just a global namespace, so it should work out of the box. And it doesn't. Why? And it's still complaining about my spaceship operator. Element type has not defined one. That's a bit sad. Yeah. As for bit set, not for indexes. Bit set POD is being compared here. These are bit sets and then separately bit set PODs. I'm a bit scared to change it. The spaceship operator also includes, well, it's an operator by itself. I have to admit, but I guess I can, yeah, well, maybe I should, you know, make the leap to C++20. What class are we in now? This compares by index. This is for the index, so I can also make here use a spaceship operator here, I guess. The OR operator is a bitwise OR. So if a bit is set in left or right, it's being set in the result. So we switch to spaceship operators here, just to annoy everyone who is using it and not using C++20 yet. I'm currently not really seeing the benefit of that. I'm also just, I can also just add it, I guess. I think that must be a member function, so it's not a friend, just a member function. Yeah, now we only captured index, left and right. Now, of course, you can use friend functions. Let me just use friend functions. So what I'm needing, let me need, what do we need? We need this and then converted. Yeah, the default one is a bit problematic. Anyway. I already have that. So we can just add a spaceship operator, which is, by the way, returning standard strong ordering. Usually just using auto. And then we separately have the normal comparisons, and these then can be removed, I suppose. Except, oh yeah, well, that one, then I have, I need more of these. Da-da. And then the question is if that even works. I guess it does. Same thing. Yeah, I'm not convinced. Let's try to see if this compiles. Oh, we still have this less than, that's not working. So a better name for this O-stream inserter operator. Let me fix this first because it's such a wall of text. No match for operator less than, O-stream and element pair. While element pair has a print on. Why is this not working? So I'm including utils has print on. Or maybe I need it in, yeah. I might need it, the trick, the thing that is being said here. This. Also in global namespace. Or not. Error utils catch all print on has not been declared. That might definitely be a problem. But it should have been defined in has print on, doesn't it? So is my comment wrong? That more looks like a utils has print on the namespace, as it says here as well. Finally, okay, with that out of the way, no match for operator spaceship types are elements type does not have it defined. Elements type is a bit set. I just added it to bit set. No, I added the 2-bit set index, not 2-bit set. Right, so we added it now to also do bit set. Yippee, it worked. Print on. Okay, let's print the pair. How are we going to do that? I have to print both bits. Yeah, well, I don't see any other way than to iterate over the bits. To some iterator and then writing it to stuff. A pair. Let's just print both as a character. So I have to convert this thing to an element, I guess. Elements, I can print elements. And so we just print element 1 and then print element 2. Is there a trick like I can just element run over elements pair? No way, right? No way that this is working. But it looks a lot like what I want. Now element pair here is elements type, which as we all know by now is a bit set. And bit set has defined, sorry for the scrolling, but what do we have defined? Begin and end. You see this? Begin and end are defined. So awesome. That might work out of the box, because begin and end is what is being used when you use this for with a colon, which now suddenly is not shown anymore. Oh, here. Oh, I don't know anymore what it was returning. I'm just gonna compile it. Come on. Hop. It has a problem with warning. Just a warning. It really is just a warning. Unbelievable. Narrowing again. Be quiet from here. Okay, let's have a look again then. What this is doing is it is calling on bit set begin, which returns a const iterator of the namespace bit set, which we are in. So that's this thing here. And then that's doing its magic. I don't really care. I'm only interested in a dereference operator then. The dereference operator should return a bit set. And I guess a bit set is a single bit set. You could put std in front of it, lconf. std colon o string stream. And of course include a header. The header that defines it. Okay, yeah, what to do? Operator, what is that thing defined? I think this is the line that it's complaining about, isn't it? 565. Yep. Narrowing conversion of from int to. Yeah, this stupid thing makes an integer of it again. Just by putting a minus in front of it. Crazy stuff. Crazy stuff. So it's sort of a bug. Yeah, what do we want to do here? Still narrowing. Is this ampersand operator not even defined for unsigned short? It seems to be converting to an int here. It's casting everything to an int. So I have an unsigned short thing, and then it's casting that to an int before doing the minus sign. Then I cast it to an unsigned short again, and then the compiler is casting it immediately back to an int. Apparently. No, it's not true. Or is it? Jesus Christ, unreadable. Yeah, cannot read it. I guess it's we're working with ints today. Everything is an int. And then at the last moment I want to make it a bit set, and bit set does not take ints. Maybe we should make it accept ints. Currently it only accepts explicitly a mask type. Yeah, I cannot make it accept int, I think. That would be ridiculous. So and then there's static cast it 2t after doing all the shit. That should get rid of the warning. If the minus converts to an int, is that not problematic then? No, because the only thing we do is just borrow a 1, so it extends it with a lot of 1s on the left side. And then I do an AND, which gets rid of all the 1s again. So now we have all 0s on the left side. And then I cast it, and that cuts off all the 0s again. Looks fine by me. Right, okay, this is already implemented. So I think I should print something now. Partitions. Yep, it prints CE. So we can now print our pair. It's going slow, isn't it? It's amazingly, it's typical C++ if you ask me. Got to do an incredible amount of work for every type and every little bit. But the result is super powerful. What we have now is really, really powerful, but it's also a lot of work to write it. Okay, we have an element pair, we can print it, we can construct it. Maybe we need more constructors, but I can't think of them right now. Maybe constructing from indexes. Let me think. I want to be able to construct, no, to generate all possible pairs. So that's probably going to happen by having 2 for loops that run over all the indexes. So I must be able to generate a pair from indexes. Yeah. Oh, I already can. If I have an index, I can construct it like this, because an index can be converted to an element automatically. Let's just write that here then. So I'm going to have a for loop that runs over all the elements. So that's an element index. Element index. Let's call it I1, which runs from element begin, I begin. think it was called ibegin, right? Ibegin, yeah. As long as it is unequal to element I end plus plus I1. And then we do that again for the second one. But this time we start with I1. In fact, we want to start with I1 plus 1, but not sure if then, I mean, yeah, well, no, it definitely works, yeah, of course. So we can just do plus 1 here. I mean, I1 is not equal to end, so, and then if I add 1 to it, it might become end. Now the plus 1 might not work. I want the plus 1 to do the same as the pre-increment without changing I1, of course, but it looks silly even. It's probably not going to compile. It's okay. Hey, let's test it out. Just print I2. No, you have a problem with printing again. No. Why? No match for operator blah, O-stream and element index. AKA bit set index cannot be printed. It's kind of strange. I'm in favor of being able to print everything. Why would I not be able to print a bit set index? Jump to bit set. Find the index. It's up here. Let's hold it like this. Index. This is here. I don't think we have an operator, O-stream operator. No, we do not. Also not one outside. Do we have any operator less than at all? And let's just shift. Here's one, but it's for bit set. You not have it for indexes. Shall I add it or shall I not add it? No, I'm not going to add it. You can convert it to an int type by adding this, and then it's printing characters, which I do not want, but... Or maybe I should add it. I don't know, I'm confused. No, I'm not confused, but... I cannot decide. Let's not add it for now. Or I can add it here, that will work. Okay, we can add it here. Standard O-stream reference operator less than standard O-stream reference s comma elements type. Want to print it. I insist. Wait, that's a bit set. I wanted to print an index, element index. Yeah, return it. Let's just print a hashtag followed by the value of the thing. But since this is a character, it's going to print a character. So we have to static cast it to an int. Okay, let's keep it unsigned. Do I want to see, is it possible to get negative values? Not really. The index is not going to be larger than 128. But if it does, then, you know. Not even sure. If you cast an unsigned char to an int, and the char is, the unsigned char is 200. Do you get a 200? Or do you get a negative number? I think you get 200. So the whole and I'm typing static again. Plus I don't think it's needed. Let's just not cast at all. Should have been static cast. Well, that worked not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nobody knows why. Why it's 10? But index is not printing anything. So it's probably unprintable characters, so I'm going to cast it to an int like that, and I'll stop complaining. There we are. The index is that it prints is 1, 2, 3, 4, 2, 3, 4, 3, 4, 4. Of course, I could have known. That's where the 10 comes from. No, seriously. It's just 5 times 4 divided by 2. In other words, 1 plus 2 plus 3 plus 4 plus 5. I'm saying that correct? No, it's plus 4, I mean. Yeah, anyway, so 1, 2, 3, 4, and then we start at 2, 2, 3, 4, and then we start at 3, 3, 4, and then we start at 4, just 4. So it is 1 plus 2 plus 3 plus 4, yeah. So we can convert this to an element pair I1, I2. Can we not? No, we print the pairs. So these are all possible pairs. AB, AC, AD, AE, BC, BD, BE, CD, CE, and DE. All the possible pairs that exist. And we're going to assign to each pair a score. That is, I need a map. Yeah, I'm tempted to use float or double for scores, but let's stick to our object-oriented approach that I really kept doing till now. We're going to make a score. Okay. And let's use doubles. It's definitely need a score clause, yeah, because we also need infinite. I don't like, you can store infinite in a double, but I'm not really liking the idea. Let's store here a double which says if it is infinite or not. Store a boolean which says infinite, but it can be positive or non-positive. Let's make an enum infinite. Positive infinite or finite. Is it pronounced infinite? No. Not writing this right. Infinite. No. No. Vedic fail. Negative. Okay. Let's put negative first because it's usually that. So a number is either negative infinite, or it is not an infinite, or it is a positive infinite. And then we have here infinite. I mean infinite. And this is only valid when m infinite equals finite. And there we have our score. And also this class must be constructed. Constructor. Default constructor. I don't know. Does this work? And we can also construct it from some value, of course. Double value. In which case infinite. Infinity. Dude. Infinite is it's finite, right? And value is m value is value. Score if it just pass this value, yeah, if you pass finite to this thing, then it's going to interpret that. So either I have to assert or we have to put in some value. That's good enough for me. And default is a bullshit. But we'll make a default constructor by putting a finite as a default. So if we now use a default constructor, we get 0 as value. Or I could just use a default here, of course, so 0, because it's really 0. Yeah, I would rather use 0 here as default. And then have no default here. Same thing, but different way to define the default constructor that results in a 0. Okay, we must be able to print it. Use my print on trick. Well, normally you just print value, but hey, that is just normal. If infinite equals negative, I'm going to print minus infinite. Else, if infinite is equal to finite, I'm going to print a value, and else it is the plus finite, plus infinite. Okay, what else do we need to be able to do? I think assignment already works, it's just compiler generated. I need to make a table or a map or yeah, we need something with all the scores for every pair. So the number of pairs, let's make that a constant expression. The number of pairs is theoretically simply n times n minus 1. Divided by 2. The number of unordered pairs. However, I'm going to store those things in some kind of array, and then we have flash hit says look again at the print function. Says something wrong. Thank you. Saves fixing a compile error. Okay, I want to have a fast lookup from element pair to a score, and I'm just going to do that by having an array. What was an int? Let's call this max score index or something like that. And that then would be the OR between the two largest elements. We OR them together. It's more like an... no, it's an int. In this case. Let's think. Yeah, I just want to have the value of an element pair. So I'm going to create an element pair, I think. And then I want to get the value of this thing. Let's add an accessory here for that. So if we do that, we get a bit set, and I want to convert the bit set then to an integer. Ouch. Yes, seriously. So that means I need to get the bit set POD. Can we convert this to a POD value, or is it protected? We can get the mask type. Set M bit mask. Wait, you can get the U-long value. That is also bit mask. Oh, of course, it's just bit mask is the type of the POD, but it's since it's a base class, you can access it like that. I have a toString, and we have everything else, but yeah. Was it now too long, or just? Okay, now I forgot it again. Can use this one, I think. Operator parenthesis. But then we first need the elements type. We get it here. Okay, get pair. 2D. So this is the elements type, and then we call that, and we get the mask type, which is the unsigned int value. Okay, I'll use the same type here then. Int 16 type, but hey, maybe we change that type later on. So is there not a way to get the type really directly from the bit set? That's the mask type of the bit set. So really it's elements type bit set. Mask type, I mean. Now this is not very clear. I would rather have this be called get mask or something like that. But well, maybe use the other one. Just get it as an unsigned long, or what was it? Get U long or something like that. Of course, I forgot again what it was. Let's jump to a bit set again. To U long, that's good enough. So this would go wrong if I changed my internal type to something that does not fit in an unsigned long. But on my machine, my unsigned long is 64 bits, and I don't even have 128 bits, so I think this is good enough. So we get it as an, we casted this function, this inline function, cast the unsigned int 16 bits to 64 bit, and then we assign it again to a 16 bit. So the compiler is going to say, and that all that const expression. So no problem that we shortly use an unsigned long. Hell, I could even use an unsigned long here, because it doesn't matter at all. But I'm not, because I just think it looks too silly. I don't know. call it intuition. Now, what to do? Oh yeah, I was going to construct this element pair. And the element pair must be constructed from the two maximum elements that we have, which I can construct from let's have a look. Element, we can construct this from elements, so I need an element. Okay, so I could do d comma e, but oops, d comma e, because but that depends on what n is, right? So what I really want to do is construct it from n and n minus 1. Can I do n and n minus 1? No, because n is already n, so you need to construct it from n minus 1 and n minus 2, which then of course requires that n is at least 2, but hey, that's definitely going to be the case. We need pairs, right? So but that's going to be an int. So now I'm passing an int to something that needs elements, and I don't think element wants to be constructed implicitly from an int. It wants to be constructed, when we're talking about indexes, from an element index. So I guess I'll just have to cast both to an element index, otherwise I'm not knowing what I want. Mr. Fatman, my day is going excellent so far. I only skipped lunch. So make me sign off in about 20 minutes, maybe 30. And then I'm gonna make dinner for myself, and then Carla will eat finally something for dinner. That would be very nice if someone can kick me off the stream in say 30 minutes ish. Damn it, I forgot where I was. There's a file with only a few hundred lines, and I already get lost. Oh, that's where we were. Well, it's getting a bit long, so let's make a const expression for the types that we need. Last element. Let's construct it like that. N minus 1. Second last element, n minus 2. And now we'll just use this here. Okay, I'll put the second last element up front, although it doesn't really matter. Now this is at least going to compile, because now we're trying to construct an element pair from two element indexes, and that is allowed because element indexes can be converted implicitly to elements, which is required for the construction of element pair. But does this work? Well, you are trying to construct an element index from an int. An element index is the index of elements type, so that is the index of a bit set, which is this thing here, index, which allows us to be constructed from an index POD. Oh, only a POD can be used, which is by the way struct like that. Note that this is not const expression. You cannot even use indexes here. You must use const expression index PODs. We're going to have a problem. But, okay, do I have element index PODs? Thought I did, yes. Well, this is the last element index. There must be a const expression. And the POD for the second last element index. I'm explicitly using braces here to remind me that this is an aggregate initialization, although it probably doesn't really matter. They're pretty exchangeable. The big difference is they also that you can use braces instead of round brackets like I'm using here. Was also pretty recently introduced. I'm not sure if it was C++ 20 or before that, but maybe 17. Yeah, my stomach hurts too. It's bad for your stomach, definitely. I know it. But hey, I was streaming. No, I was coding, I mean. So, I'm an idiot. I know. It's worse, man. I also don't go to bed. And then when I'm in bed, I don't get out of it. But I'm sure the people that view... my viewers want to escape reality instead of being reminded about all the misery in the world. Let's just talk about C++. I'm going to make dinner in say 20 minutes or something. Okay. So this is index POD, which is index POD of bit set, which is thus a struct which we can initialize with aggregate initialization, and because it does not have a constructor. So that should work. And I was explaining the big difference of the braces is that this cannot be a function. And if it would have a constructor and I would call it like this, then sometimes the compiler gets confused and thinks that that really I'm declaring a function here for declaring whatever. So sometimes it's really required because sometimes it works in both ways, and sometimes you really need to use braces if you want to avoid that it's things that you're talking about a function. Well, let's not talk about that. I've had so many therapies, and not for eating disorder, by the way, but that I became a psychologist myself almost. So I did a lot of volunteer work to help mostly kids and teens with psychological problems. And I was pretty good at it as well. Because I just understand them, if you get what I mean. Okay, we have this, these PODs values, and I can construct an element index from a POD. So now we can construct this from the last element index. And that this is not going to compile, unfortunately. because the constructor of element index does take an element index POD, so that would be the bit set index again. And it does take an POD, but it's not marked with const expression. And actually I have no idea why not. If you ask me, I wrote this a long time ago and then I copied it and recently I copied it, but it's still actually really old code. Just adding a const expression here. Why not? Why not? Could even add one here. But okay. In the light of index PODs can be const expressions. Now we can have index const expressions out of nowhere. Nobody knows why I didn't do that before. Almost confused about it. Often I think, well, I must have had a reason, but this is more like I didn't know better, I think. Okay, so we can now construct these const expressions. And then we can construct an element pair from element indexes if it is marked as const expression. And it's our current code, so we just do it. And then assert is not compiling anymore. Oops, assert is not a const expression. And that is pretty annoying. How can we do an assert in a const expression function, which is sometimes const expression and sometimes isn't? It's actually an FAQ question if you ask me. Assert in const expression function. Let's say assert, a normal assert. Well, that's confusing. It said addressing it C++14 is trivial and it just adds a const expression, but the assert is still there. As far as I know, that shouldn't work. Oh yeah. With testing Clang, it indeed works, but with DCC you can. It doesn't work, and the reason is that it is defined like this. So then what? Well, okay, so he's implementing it by putting the cert in an lambda. However, I think that then if it fails, it's still going to complain. Oh wait, this is a different kind of thing. It's an assert not as an it's just printing it then. Why am I using assert in the at all then? I don't know. Could try this. Let's just try it. So, according to that website, the extra should work in a inside a const expression function. So, I don't know, maybe. So, being a bit long. Let's try this. Failed. In constructor const expression element pair invalid type for parameter 1 of const expression function element pair blah blah blah. Element is not literal because element is not an aggregate, does not have a trivial default constructor, has no const expression constructor, does not, etc. Element is not const expression. So we're using element constructor. Which element constructor are we using? Doesn't say. I'm guessing going from index to element. Maybe it is this line. No, it's not. But yeah, we're using this element thing from element index, so this must be a const expression as well. I probably can add const expressions all over the place, now I think about it. Oh, this cannot be a const expression, because this is using LSSBI, which is not a const expression, or is it? Well, not currently, but I might be able to make one with it. And then I'll end up adding const expressions everywhere. Let's not do that until we need it. I'm not sure that these are const expressions then. Index to bit, it's static, but yeah, we also must make this a const expression then. Which means that this must be an X assert. Hopefully that works. Which means that element I end must be a const expression. We are still adding const expressions all over the place. Well, this might as well. Const expression. And yeah, what else? The index to name. Okay, I'm just going to add const expressions all over the place, apparently. No dinner. This one, const expression. Okay, I'm tired of it. Let's try it again. Call to non-const expression function, index from index. What? So this one. Yeah, copy constructor. And yeah, getting all the const expressions correct is also a lot of work. But we need it in this case, ish. Want to do it in a clean way. The result is anyway required to be const expression. I want to use it as a size of an array. This looks like the copy constructor. Index to name, function operator is not a const expression, obviously. Not even pointing to it this time. It's nice. Invalid return type. Looks like it says bit set needs a const expression copy constructor. Thought you just added that. Bit set. No, it did not. There was something else. Const expression. I'm just going to add them one at a time. Why do it fast when you can do it slow? I'm just kidding. What is this with the invalid return type? It used to work. It's the exact same error as I had before. Yeah, YouTube knows how to appreciate me. I even get phone calls from Biden saying that he gets really tired of getting recommended my stream all the time. Nothing works anymore. Getting tired of it. I'm going to cook dinner. Wait, I meant to make seed tags. Index to name, index to bit. Stop complaining about that. I think so. Index. Yeah, I've read it at Batman. So you're not really fat then? You're not eating and you're feeling hollow? I think I cannot think anymore at the moment. Anyway, I don't know what's going on here. I don't understand the exact error. In static member function, static const expression, elements type, element index to bit. Element index, that is definitely index to bit then. Invalid return type. That's silly, but okay. Elements type. And then it starts talking about blah 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 is not literal. I mean, is now invalid or what the hell? So I think I'm going to change this slightly, as in. I'm guessing that this is not a const expression then. Everything is a const expression. Everything is a const expression. Still invalid return time. It's good to have a regular thing in your day, yeah, and that's why I should eat at fixed times and go to bed at fixed times, etc. Okay, it's a time. It's difficult, but you have to start somewhere. Like I said, I'm going to cook dinner, so I'll